In this lecture video, we'll learn about normal distributions and z-scores. Suppose we have a normal distribution with mean 49.7 pounds and standard deviation 6.2 pounds. The question is, how far from the mean is 57.3 pounds? And the follow-up question is, how many standard deviations away from the mean is 57.3 pounds? Let's start by focusing our attention here on the first question. How far from the mean is 57.3 pounds? We are given a mean of 49.5 pounds. So this data value, let's call it x, of 57.3 pounds is 7.8 pounds from the mean. Now let's consider the second question. How many standard deviations away from the mean is 57.3 pounds? We first found how many pounds our data value was from the mean, but now we need to find how many standard deviations our data value is from the mean. We are given that the standard deviation is 6.2 pounds. So our data value of 57.3 pounds is more than one standard deviation above the mean. But exactly how many standard deviations above the mean? We can find out by taking 7.8 pounds and dividing it by the standard deviation, 6.2 pounds. This gives us a value without units of 1.26. We found that the data value of 57.3 pounds is 1.26 standard deviations from the mean. What we just calculated is called the z-score. We have a data value, and we found out how many standard deviations from the mean that data value is. Think about how we calculated this. We first subtracted the mean from the data value, and then took that difference and divided it by the standard deviation. That's exactly the definition of a z-score. For a given data value x in a normal distribution with a mean mu and standard deviation sigma, the z-score is the value x minus mu divided by sigma, or the data value minus the mean divided by the standard deviation. Let's find some more z-scores for this same example. With a mean of 49.5 pounds and a standard deviation of 6.2 pounds, we can calculate the z-score for any data value. We already calculated the z-score for 57.3. We took our data value, subtracted the mean, and divided by the standard deviation, or 57.3 minus 49.5 divided by 6.2, which gave us a z-score of 1.26. 57.3 is 1.26 standard deviations from the mean. Now let's calculate the z-score for 42.0. This time, our x value is 42.0, but the mean is still 49.5, and standard deviation is 6.2. Notice that 42 minus 49.5 is a negative number, negative 7.5. And when we divide by 6.2, we have a z-score of negative 1.21. What do you think it means to have a negative z-score? Consider where 42 is located in relation to the mean. Notice that 57.3 is over here and has a z-score of positive 1.26. 42.0 is over here. It's less than the mean. It's located 1.21 standard deviations below the mean. A positive z-score tells us that a data value is above the mean, and by how many standard deviations, while the negative z-score indicates that a data value is below the mean, and by how many standard deviations. Let's calculate the z-score for 49.5. In this case, z is equal to 49.5 minus 49.5 divided by 6.2. 49.5 minus itself is of course 0, so we have 0 divided by 6.2, or a z-score of 0. That means that the z-score of the mean itself is 0. Think about why that's the case. We're asking how many standard deviations from the mean 49.5 is. 49.5 is the mean, so it's 0 standard deviations from the mean. Finally, let's calculate the z-score for 30.8. We'll have z equals 30.8 minus 49.5 divided by 6.2. 30.8 minus 49.5 is a negative number, negative 18.7. And dividing by 6.2, we have a z-score of negative 3.02. 30.8 is more than 3 standard deviations below the mean. We can translate any data value for any normal distribution into a z-score, which tells us exactly where that data value is located in relation to the rest of the dataset. That concludes this lecture video on how to calculate z-scores for normal distributions.